Alternative to practical, question 1 we did in the first part. So we'll do question 2 and onward. Question 1 was about planning experiment. So we already did this first question. Now question 2 from the topic time period. So in the first part, a student is investigating whether the diameter of a pendulum bob affects the period of pendulum. Like period means how much time it will take to complete one vibration or oscillation. Figure 3.1 shows a pendulum and one complete oscillation is there. The student has the following apparatus. There's a pendulum bob which is made from polystyrene having a diameter 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, and 5 centimeter. A supply of a thread and a pair of scissors, mainly just to cut the length out of it. The clamp stand is there. You can see the clamp stand, the thread is there. Scissor to cut this thread, like certain length we select. And the plan and experiment to investigate whether the diameter of a pendulum bob affects the period of oscillation. You have to plan experiment. List any additional, so whenever you're writing the experiment, you should always try to answer those points according to the sequence. The first one.
Stopwatch.
So list any additional apparatus we need. What additional apparatus we need? We need a stopwatch. What else we need?
Do we need a ruler?
Yeah, ruler, the scale, or a meter scale, or a meter rule. The next part, explain briefly how would you carry out the investigation, means the procedure of this experiment. So how we carry out this experiment, like if you want to work out the time period. So first we measure the length of a pendulum, certain length of pendulum like 30 centimeter, 20 centimeter length of a pendulum. Yeah, use stand and clamp, use a certain length. Then mark the mean position, like the center position. Then displace the pendulum to extreme position. This is extreme position, and the moment we release from extreme position, we'll start the timer. And we record the time for not for one oscillation. We like fiducial points or mark mean and extreme position is the same thing. Then we record the time for 20 oscillation or 10 oscillation. Why not for one? Because one won't be that accurate. So we mark mean and extreme position, clamp the pendulum with a stand, and then displace to its extreme position, start the timer and record the time for 20 oscillation, and then divide the time recorded by number of oscillation to get the time period. And then repeat the procedure with different size of, because we are finding how the diameter of a pendulum affects. So we'll use a different size pendulum to identify how it affects the time period. So procedure, it's always the first one was use a stopwatch and the meter rule or a meter scale. And the second one, the procedure, that measure length of pendulum, because that we need same for all. So measure the length of a pendulum. And we'll mark mean and extreme position. Then displace the pendulum. To extreme position. Then we'll start the timer or a stopwatch and record time for 20 oscillations. And divide the time by number of oscillation. Then repeat the experiment. With different size of pendulum. Yes, you can also say 15, you can also say 10. It's 20 is not, it's a hard and fast 20. It can be 10 oscillation, 15 oscillation, that's fine. Yeah, repeat and take average. Yeah, repeat, take mean, average. That's also a point. State the key variable that you would control. So what?
Diameter of the bob.
No. The diameter should be changed because
Length of
your
pendulum.
your length of, because you're determining whether the diameter affects the time period. So you should change the diameter. That is the thing which you are investigating.
Extreme position.
Yeah, amplitude, that's right. The distance between mean and extreme position. So variable which we should keep constant. One you mentioned length, that is right. The distance between mean and extreme position, which is also called amplitude. What else? Air current surrounding wind or air current.
Can it be same length of stand?
Yeah, that is like the same idea. Length I mentioned here, it's the same thing. Then number of oscillation. Look, when you're changing the size, as you can see, you have a polystyrene with a, you have bulbs of which are made from polystyrene with different diameters. So it's obvious if they have different size and there is the same material, so they will have different masses. That you cannot keep same. Yeah, it's mentioned length of a pendulum. Length of a pendulum or a length of a thread is the same. But length of a pendulum is more appropriate rather than length of the string. Then draw table or tables with a column heading to show your displayed result, like table with a column heading. So whenever such question is there, so one is the size, the diameter. Another one is time for 20 oscillation, and then the third one is the time period. Like we have a size in millimeter is there, it's given in centimeter. So size in centimeter. So cm centimeter, then time for 20 oscillation, and then time for one oscillation. In this column, you can complete this column because they mention here that we have different sizes available, but it's not having mark to complete the table. Like 1, 2, 3, 4, 5 are there. So you can mention here we have 1, 2, 3, 4, 5. This column you cannot because you are not doing an experiment. Then explain how you will explain how you would use your reading to reach a conclusion. Like how we get the answer, how we don't have to say that what will be the result. We have to say how we will reach the conclusion. So whenever we want to reach a conclusion, we want to find a relation between the two quantities. The best way to reach a conclusion is plot a graph. And what graph we'll plot? We will plot a graph between diameter and the time period. So to reach a conclusion, we'll plot a graph between the size or a diameter and the time period. But you don't have to say what will happen to the time period as a diameter is changing. That is not the question. The question is you just investigate what is the effect of, like you have to plan an experiment to investigate how a diameter can affect the time period. Is it clear, this whole experiment?
Yes, sir. Clear.
Moving on to the next question, question 3. The student uses a pendulum to determine the value. Okay, the graph normally the independent variable, like we are changing a diameter, so you can plot a diameter here and the time here. That's it. But you don't have to mention what will the shape of the graph, how it will look like. You can mention this as well, plotting it. Question 3, a student uses a pendulum to determine the value of acceleration. The independent variables are on x-axis. But because as we are not doing an experiment, so we don't know whether it will affect or no. That's why we are investigating. So here both are possible. You can make a time on x-axis or diameter on x-axis. So student uses a pendulum to determine the value of acceleration of a free fall or a gravity. Figure 1.1 and 1.2 shows the apparatus. You can see the apparatus. On a figure, measure the length. So you have to just use your scale or a ruler and measure the length. It's not necessary that marking scheme answer and your answer will be same. So the marking scheme answer and this answer might not be same. Reason is that because the paper size will be different. So what is the length for the, can you say what will be the length? What is the length? 3.6,
3.5.
3.5,
3.65.
3.65. So that you will write accordingly. Like actually the marking scheme answer is the range is there from 4.1 to 4.2. But again, as I mentioned, it's not 3.4, 3.5, 3.6. What you get according to that you will write. So we'll write also 3.6 because that's our answer, or 3.5 you can write accordingly. Measure even for the same class, why you are getting a different answer, because the size, the scale of the printer might be different. That's why you're getting a different answer. So the actual answer should be 4.1 to 4.2, but according to you will write here. I will use a marking scheme answer, but you will solve this question according to your answer. So the marking scheme answer 4.1 or 4.2, but write your answer here. Don't copy the marking scheme answer as it's not, or take any value like 3.5 is there, 3.4 is there. Then student adjusted the length of a pendulum to be 50. Now the new length is 50. The length is measured by, the length L is measured to the center of the bow. Explain how student avoid a parallax error when measuring a length. So he should look perpendicular to the scale, see perpendicularly, look perpendicular, and he can also use a aid of a set square, like look perpendicular, use set square, which can also reduce the chance of a parallax error. Then student displaces a pendulum. How set square can be used? Like for example, say we want to measure, so what we will do, we'll place a ruler next to this, like this is a meter rule or a meter scale, and we place a set square. So we can identify the exact position. So using a set square, we can also overcome the line of sight error. Is it clear? The next one, the student displaces the pendulum bob slightly. Yes, scale can also be adjusted vertically by using a set square, Rafi, that's right. like as I drew here, you want to make sure that the base, like scale is exactly vertical. You want to make sure that the scale is exactly vertical. So you place another set square here. To show that it is exactly vertical. If it fit into the space, it means it's exactly vertical. Then this is the time for 20 oscillation. What will be the time for one complete vibration? How we get this? What I should do?
So,
27?
Mr. 27.8 divided by 20 equal 1.39.
1.39. Okay. So this will be equals to 1.39. And the unit will be second. Then measuring a time, because we need the time for one oscillation. If we need the time for one oscillation, or we need the time period, so time period is a total time divided by number of the vibrations or number of oscillation. That's a formula. Time period is a total time divided by number of oscillation or vibration. So total time was 27.8 and number of oscillation are 20. That's why it is 27.8 divided by 20. So we get for one each. Measuring a time for a large number of oscillation rather than one oscillation gives more accurate. Suggest one practical reason why 200 oscillation is not used, because the pendulum will stop oscillating or it slow down, or we might miscount because 200 is a very big number. So there might be a miscounting. Yeah, pendulum lose energy, slow down, stop vibrating. You can practically it will not even vibrate for this many oscillation. 200 is a very high number for oscillation. Then we need t square. What is the meaning of t squared? Means we were having a value of a t which was 1.39. We just need t square, means we have to just square. So 1.39 square. What's the answer for 1.39 square?
1.93.
So 1.93, and the unit will be second square, because this was time second and this is time square, so unit will be second square. Then we have to use a formula. For paper 6, you don't have to memorize any formula. Calculate the acceleration due to gravity using a formula that g is equals to 4 pi square L divided by t square. What is the L here? L we arrange 50 centimeter, but this should be in meter because the value of the g is in meter per second square. So if you see, it's a continuation of the question. The student adjusted the length to be 50. So 50 centimeter, but in meter, it will be 0.5 meter. So T equals to 4 pi square L by T square. So we just substitute the values. So this will be 4. Pi is 3.14, then square, times the length is 0.5 divided by T square. T square we calculated, that was 1.93. So this was 1.93. What's the answer?
3.25.
The final answer for this, the value for the gravity?
10.2.
10.2. Solve numerator and denominator separately, and then at the final last divide them. It should be 10.2. Like it should be in the range as gravity value is 9.8. So it should be closer to that. If you are getting a wrong, different answer, like very different value of gravity, it means there's some mistake. Then student check the value for the gravity for acceleration of a free fall in a textbook, and the value is 9.8. Suggest a practical reason why the results obtained from the experiment may be different. Like student is getting 10.2. What might be the reason? What student is measuring here? Like what student is measuring? Student is measuring a length. Student is measuring a time period. So what might be the reason? Maybe there is a like parallax error in measurement of the length. or reaction time in measurement, like reaction time is involved when measuring a time interval that may leads to an error. Their time to react, that is right. We have to mention experimental technique here suggests practical reason why the results obtained are different. So why practical? You cannot mention air current here. That is like air current is in the surrounding, but if you get like measurement, reaction time is there, or that leads to an error, or the error in the parallax error in measurement of the length. Any one you can mention. Suggest two improvements for this experiment. How the time period experiment can be improved. Whenever you want to improve such experiment, you should always repeat the experiment for improvement, and even like increase the number of oscillation, take average, calculate the mean. Yeah, repeat, take average, calculate mean, all counted as one. If you mention repeat, you mention take mean, take average, you mention any of them, that is considered as 1 point. Or the second way to improve the experiment, whenever you want to include, like if you want to identify the errors, you should always plot a graph. And basically, when you are plotting a graph, you are improving in it, because when you plot a graph, you need more values. And how you will have more values? By repeating it. So it's the same thing like plot a graph between the quantities. So plotting a graph and spot for an anomalous result, that is right. Like an anomalous result means the results which are not in the range, it's not in the sequence. That is, we can identify. And how we identify from the graph, like say if there are points and one of the point is too far from the range. So it means this result appeared to be anomalous. The time axis will be there, and length. Is it clear discussion?
Yes, sir, clear.
So in this question, a student determined the acceleration of a free fall using the value of a free fall g using a pendulum as shown. On a figure, measure a distance d. Use your scale or a ruler, measure the distance d. How much is this, the value for d? What is the value of d?
3.6.
3.6.
3.6. So again, as I mentioned, the marking scheme answer will be different as your paper size is not same as the exam sheet. So 3.6, so we write 3.6. The next part, the figure 1.1 is drawn 1/10 of actual size, means the figure size is equals to 1/10 of the actual size. If the figure size is 3.6, what will the actual size? The actual size will be 10 times. Like figure is drawn,
So multiply by 10.
multiply by 10. So 3.6 times 10, we'll get that as 36. So this is 3.6, this one is 36. The next one, the student displaces a pendulum bob so that he's showing, and he measure a time for 10 complete oscillation. This is a time for 10 oscillations. Why we multiply by 10? As you can see, we want an actual size. In the question they mentioned we need calculate the actual size. So figure size is 1/10th of actual size. That is, they specify the scale. If I need actual size, so actual size will be figure size times 10. Figure size was 3.6. So 3.6 multiplied by 10, the actual size will be 10 times. That is why it is 36. Then what is the time for 10 oscillations? Use a screen annotation to complete time for 10 oscillation. So this is 14.06. Don't forget to write the unit second. Then the time period means time for one complete oscillation. So what is the time period? So it is 14.06. This time, because if we want a time period, the time period is the total time divided by number of vibration or number of oscillation, here 10. So this will become 1.406 second. Then t square. So t was 1.406. What will be t square? Square of this number.
1.97.
After 7, what is the number? What is this full number?
1.9768.
So 1.97, so it should be 1.976, so it should be 1.8. Three significant figure when you write, because you have to round off 1.976. So this will become 1.97, 1.98. And the unit will be second square, because this is t. Yeah, your answer should be three significant figure. Even when I write here, I wrote here 4, so I should write here 1.41. Write your answer to three significant figures. Then we need the value for the gravity, that is 20 divided by t square. So this was 1.98. So 20 divided by 1.98. What's the answer?
10.1.
So again, we are getting 10.1, and unit of acceleration, Newton per kilogram or meter per second square. 10.101, but rounded off to three significant figures, so it will be 10.1. The student adjusted the pendulum until the distance d is measured. He repeated procedure and obtained a value. On the dotted line above, write the unit for t square. So what is the unit of t square? That is second square. Because unit of time is second, so time square will be second square. Now, student calculate the value. Again, so g, he calculated 40 divided by t square. So 40 divided by t square, this is 3.94. What's the answer?
10.15.
10.15. So when there is a 5 in odd number, so we just make it round. So it will become 10.2. And the unit, don't forget to write the unit, meter per second square or Newton per kilogram. Then another student state that the repeating experiment improved the reliability of the value of G. State two changes that you would make to improve the reliability. Stopwatch cannot be changed. Like what changes we must do for this experiment to increase the reliability? Yeah, plotting a graph. Okay. What else? Or you plot graph to identify an MLS. Okay. Then what else? repeating or like repeating with the more values, larger values. Repeat with more values of a D, like when we have more values, because as you can see, student or a student did for only one of the value of a D. Like he just one time he adjusted, if you see the beginning of experiment, he just adjusted this length and he just got the value of a gravity. So he should do the experiment with more values of a D, or do it for more oscillation. State one precaution that you would take in this experiment to obtain accurate readings. What should be the precaution?
Read perpendicular to avoid parallax error.
Yeah, good. Read perpendicular or reset the stopwatch also. Like the stopwatch must be reset when you're measuring a time or measuring mark mean and extreme position as well, as they did not mention anything about, or the meter rule should be like avoiding a parallax error, mark the fiducial points, or fiducial points are refers to mean and extreme position.